your oxygen is disconnected, that there's some alarm system that's going to warn you if the oxygen is disconnected. Right, so then you come to your pipes and you take the oxygen out. Alright. Now at this point you should hear a Ritchie whistle. So, okay, this machine's Ritchie whistle isn't working. Okay. So but there must be something that's going to warn you, some kind of alarm that's going to warn you if the oxygen pressures fall. Right. While you have this disconnected, you then test if there's oxygen in your cylinder. Right. So then you open your cylinder at the back. Right, and your flows must return to 8 liters per minute. Right. You have to keep the oxygen cylinder closed. Okay, remember the pressures here are 4 to 5 atmosphere. The pressure in the bottle is 137 atmosphere. Right, so if you don't close your cylinder, it's just going to empty throughout the anesthetic. Okay, and then it's going to be empty when you need it. Right. When you close that, you should again be hearing your Ritchie whistle. Okay, to tell you that it's the oxygen pressure has fallen. Right. Reconnect your oxygen, right, and then you do what is called a tug test. Okay, so basically all you want to do is you want to tug on all your pipes to make sure that they are properly fitted. Right. Alright, so now let's just assume that the everything is still connected. Right. Now I come and I look at the pressures that I've got. So the pipeline pressures are given here for air, nitrous oxide and oxygen. Right, and you want that to be between 4 and 5 bar, or 4 or 5 kilopascals, or 400 to 500, 4 to 5 atmospheres, or 400 to 500 kilopascals. Right. While my oxygen cylinder is open, you also have a look at your cylinder pressure. Cylinder pressure. Right. Now, oxygen the critical temperature of oxygen, remember the critical temperature is that temperature where above it the gas cannot be in a liquid form anymore. Okay, so if you go above the critical temperature of a gas, then the gas has to be in gas form. Okay, and the critical temperature for oxygen is sub-zero. Okay, so for all practical purposes, oxygen is always going to be in gas form in a cylinder, right? Which means that you can use the pressure to gauge how full the bottle is. Okay, now all bottles are filled to a capacity or to a pressure of 137 kilopascals, 137 atmospheres. Okay, so if you've got half of that, if you've got a bottle with 65 atmospheres, then you know the bottle is half. Okay, or if it's 30, then you know there's a quarter left in the bottle. Okay, and we want at least a half a bottle. If the bottle isn't at least half, then you want another cylinder nearby to exchange it. Right. Nitrous oxide. Now we don't use nitrous oxide cylinders very often anymore, but nitrous oxide's critical temperature is about 20 degrees, around about room temperature. Right. So a lot of time you're going to find that the nitrous oxide is going to be in fluid form. Or, for all practical purposes, they're always going to be in fluid form. So what happens is that as the cylinder empties, the pressure is going to stay the same, right, until at some point where most of the fluid has been converted to gas, and only then is the pressure going to start falling. Okay, so by measuring the pressure in a nitrous oxide cylinder, it doesn't give you an indication of how full the bottle is or not, or the cylinder is or not. Okay, so to know how full the cylinder is, you have to weigh it, alright, to see how full it is. And the manufacturers give you guidelines as to what weight a full cylinder should be and what weight an empty cylinder should be. Okay, but we don't use nitrous oxide cylinders that often anymore. Right, so now we want to know that our rotometers or our flow meters are working properly. Right. Remember, these are glass tubes, okay, that has got a variable orifice. Okay, so at the bottom the orifice is narrow and at the top the orifice is broad. Right. So and the gas flow from the high pressure system through these tubes, right? And depending on how much the flow is through that tube, the rotometer is lifted, okay, to give you a reading of how much liters per minute of flowing. Right. So it means if those rotometers are stuck, there's an obstruction to the flow in the pipeline. Okay, so we go through the rotometers and we open them up completely, and you want to see that the rotometer goes up and comes down. And you want to do the same for nitrous oxide, and you want to do the same for air. Okay, if the rotometer is at all stuck or it doesn't go up or down, then they mean it is obstruction. Then the rotometer is obstructing the gas flow. Right. You also want to check that there's some safeguard that you cannot give an hypoxic mixture. Right. So there must be some connection between the nitrous oxide and the oxygen, so that you're not able to open the nitrous oxide without giving oxygen. Right. So now some machines like the Draeger machines, what they do is, as you turn the nitrous oxide, the oxygen goes up automatically as well. All right. While as the Datex machines, or the Fabius machines, the nitrous oxide just doesn't open unless you've got some oxygen open as well. Okay, so, but you have to test, whatever the mechanism is, you have to test that there's some way of linking the oxygen with the nitrous oxide. Because if you are able to give only nitrous oxide, it's dangerous to use it like that, and it's not allowed. Okay. All right.
So ek was dan vra, die suurstof, is daar altyd vanaf die muur en die silinder?
Ja.
So albei moet in plek wees, gekoppel wees.
Ja. Ja, die cylinder mounted at the back of the machine. Okay, so you have to make sure that it's properly mounted. Okay, and that's why you open it and close it, because you also have to see that it's not leaking here. Okay, because it seals with the O-ring, and sometimes those O-rings break or whatever, and then there's a leak here. So you have to make sure that it's not leaking.
So as jy op die vloeimeter kyk vir suurstof, hoe weet jy of van die muur af kom of van die silinder af?
Jy gaan nie weet nie. Jy gaan weet, maar as jy nou net inkom en die ding staan aan, gaan jy nie weet nie. Alright, maar as ek die silinder is onder normale omstandighede toe. Jy maak hom net oop is in 'n noodsituasie as jou muur se suurstof soos dit hierdie naweek gebeur het. Die suurstof vir een of ander rede ophou. Alright, dan kom jy agter die masjien, jy maak jou silinder oop.
So die Richards vlekkie sal net vir sê van waar die suurstof.
Nee, al die Richards vlek vir sê is as die vloei in die suurstof minder raak. Okay, as die druk in die suurstof val, dan gaan jy Richie vlekkie af. Okay. Alright. While we're busy at the machine, you also want to check your vaporizer or test your vaporizer. Now the vaporizer have to be able to easily open and close. Okay, it shouldn't be stuck. The dial shouldn't be stuck. This one is mounted with side ports, but most of the modern vaporizers are mounted onto a bar that seals also with O-rings. Okay, so you kind of just place it onto the bar, and you have to lift it to see that the O-rings are still intact, because if the O-rings break, then there's going to be a leak on the system. Alright, so you want to just make sure that, and they should be, they should sit on the bar horizontally. Okay, so you should see that they sit properly horizontally, and then see that the O-rings aren't broken. Okay, you'll see in theatre, but anyway, but this one you can also check, just make sure that it's not leaking from the sides, and then you're going to have a look if there's vaporizer in, okay, and it shows you between which levels the meniscus of the vaporizer should be. Okay. So that's our high pressure system. To recap it, you want to switch your machine on, you want to put it at 8 liters per minute, you want to disconnect your oxygen from the wall to make sure that there's a Ritchie whistle of some kind that's going to warn you if the oxygen pressure falls. Right, then you open your cylinder at the back to see that the flow returns to 8 liters per minute. At that time, you can also check the pressures in your oxygen cylinder, which is going to be an indication of how full your cylinder is or not. Right? You close your oxygen cylinder at the back. You'll hear your Ritchie whistle again. Alright, and then you can plug your oxygen back into the wall. Right, then you're going to do your tug test to make sure that your pipes are secured properly, and then you'll see all the pipes has also got a different pegs. Okay, and this is called the peg index. Okay, so one's the pin index, and the other one's the peg index. Okay, so every gas is unique. Again, that it would only fit their specific mount. Right? And if there's any work done in a theatre complex on any of the gas supplies, okay, or anything, then the engineer have to give a certificate to the head of the department to confirm that if this says oxygen or this says oxygen, then there's oxygen coming out of it. Okay, if this says nitrous oxide, then there's nitrous oxide coming out of it. Okay, if you don't have that letter from the engineer, okay, then you are medically legally liable if this isn't oxygen as it said. Okay, so if there's any work done in a hospital, then the engineer have to give a certificate to the head of the department to confirm that they've tested that this is definitely oxygen. Right. There is in Bloemfontein 10, 20 years ago, there was